Hello and welcome to Algebra 1, Lesson 46. In this video, we're going to learn about adding and subtracting rational expressions. So when we're adding or subtracting rational expressions, we need to first have a common denominator. It's just like when we added or subtracted fractions back in pre-algebra. So when there's a common denominator, all we need to do is add or subtract the numerators and place the result over the common denominator. All right, for the first one we're going to look at, we have u minus 6v over 16u squared, then plus u plus 2v, again over 16u squared. So you can see that we have a common denominator of 16u squared. So just like with fractions, all we need to do is add the numerators and put the result over that common denominator. So just to show you real quick, it's the same thing as if I had something like, let's say 1/5 plus 2/5. I have a common denominator of 5, so that just stays the same. And then I just add the numerators. 1 plus 2 is 3, and so I get 3/5. So here I'm going to do the exact same process. It's just going to be a little bit more tedious because I have some variables involved, right? It's just going to be more work. So I'm going to keep this part the same. So 16u squared, that will remain unchanged. Then for the numerators, I have u minus 6v, so u minus 6v. Then plus u plus 2v. Kind of expand this out a little bit. Let me write this in the center, 16u squared. And I just want to combine like terms in the numerator. So u plus u is 2u. And then negative 6v plus 2v is going to be negative 4v. And again, this is over the common denominator of 16u squared. Now, in a lot of cases, you'll stop and you'll say, this is my answer, right? I'll box this up and say, I'm done. But there's a problem here. Remember, when we report our answer with fractions, we want to see if we can reduce the fraction to its lowest terms, right? Or simplify it. You're always expected to do that. If I had something like 2/15 plus 3/15, I have that common denominator of 15. 2 plus 3 is 5. Now, I wouldn't leave my answer this way. I would say, okay, the greatest common factor between these two is 5. So I would divide the numerator by 5, and I would get 1. I would also divide the denominator by 5, and I get 3. And so my simplified answer here is 1/3. So I'm going to do the same thing here. And all I really need to do is just factor it to see what the GCF would be. So in the numerator, I can pull out a 2. So this would be 2 times the quantity u minus 2v. In the denominator, I have a 16. Now, I don't need to go through and write 2 times 2 times 2 times 2. I know 16 is 8 times 2. So I'll just write 2 times 8 and then times u squared. So I can see that I can cancel this factor of 2 with this factor of 2. And so I have reduced this rational expression to its lowest terms. So I have u minus 2v as my simplified numerator over 8u squared as my simplified denominator. And there's nothing else that I can do here. Remember, this is a subtraction sign. You can't go through and start going, okay, this is going to cancel with this. I see that all the time. Or students will go, okay, well, this is going to cancel with this, and that's going to give me a 4. That doesn't work that way. It's got to be factors, right? So we cancel common factors. Here, this is multiplication. I am multiplying 2 by this u minus 2v, by that quantity. I am multiplying 2 by 8u squared. So this is multiplication. These are factors, so I can cancel common factors. When I think about u minus 2v, these aren't factors. Okay, so I can't go through and just start canceling things. So it's very important that you understand that. We cancel common factors. All right, so again, the answer here is u minus 2v over 8u squared. All right, let's take a look at another one. We have 2m minus 5n over m minus 3n. And then we're adding to this m minus 4n over m minus 3n. So again, we have one with a common denominator of m minus 3n. So we're just going to leave that as it is. And we're going to add the numerators. So the numerators, we have 2m minus 5n plus m minus 4n over, again, that common denominator of m minus 3n. So just combine like terms here. So 2m plus m is 3m. This is 3m. And then negative 5n minus 4n is negative 9n. And this is over m minus 3n. So again, I want to think about what I can cancel. In some cases, you're not going to be able to cancel anything. In other cases, you're going to be able to cancel a lot. So if I look at m minus 3n, I can't factor that at all. If I look at 3m minus 9n, I can pull a 3 out. So let's just do that. Just pull out what you can and see what you get. So I'm going to pull out a 3, and I'll get m minus 3n inside. And we can see that now we have a common factor between numerator and denominator of m minus 3n. Again, if you want to, you can write this as times 1, so that's completely clear. And then cancel this with this. And what I'm left with is 3 over 1, or just 3, as my simplified answer. Okay, so now let's take a look at one with subtraction. So we have v plus 8 over 24v minus 12. And I'm subtracting away 7v minus 6 over 24v minus 12. Very important that you realize that this whole thing is being subtracted away. So that means I want to put my numerator inside of parentheses when I go to do the subtracting. And we'll do that in a second. Now, I have a common denominator. That common denominator is 24v minus 12. So I'm just going to put 24v minus 12 down here. And this is over. I have v plus 8 minus, I'm subtracting this whole thing away. Please don't make the mistake of just putting minus 7v minus 6. That is wrong. I am subtracting away the 7v and the negative 6. So there's kind of two things you can do. You can change this to plus, okay, this to plus, and then you can change the sign of each term. So this can be plus negative 7v, and then since this is negative 6, it would be positive 6. You can do that. Or you can do it kind of the slower way and just put a minus sign out in front of parentheses. So 7v minus 6. But again, if you see a negative outside of some parentheses, what do? In order to drop the parentheses, you've got to change the sign of each term inside. Remember, multiplying by that phantom negative 1. So we can do plus negative 1. Again, negative 1 times 7v is negative 7v. And then negative 1 times negative 6 is plus 6. So any kind of way that you look at it, it's going to be minus 7v, and plus 6. Okay, so if we combine like terms, v minus 7v is negative 6v. And then 8 plus 6 is 14. So plus 14. This is over 24v minus 12. Now, again, we want to look to see if we can simplify anything before we report our answer. I know in the numerator I can pull out a 2. I could also pull out a negative 2 if I wanted to. It's just kind of up to me. Let's just pull out a 2, and I'd have negative 3v plus 7. Down here, let's also pull out a 2, and I'll have 12v minus 6. Now, I can't really factor this any further, so I really don't need to do anything else down here. I would just cancel this common factor of 2 between numerator and denominator, and then I will report my answer as negative 3v plus 7 over 12v minus 6. All right, so the harder scenario occurs when we add or subtract rational expressions without a common denominator. It's the same thing as if we added or subtracted fractions without a common denominator. You've got all these extra steps. So with fractions, if I have something like, let's say 1/4 plus 2/3, I find my LCD. In this particular case, the LCD is 4 times 3 or 12. I change each fraction into an equivalent fraction where 12 is the denominator. So I multiply this by 3 over 3. Remember, that's a complicated form of 1, so it just changes the way it looks, not the value, right? So it's still worth 1/4 in the end. And then plus, I'll have 2/3. I'm going to multiply this by 4 over 4. Again, just a complicated form of 1. So 1 times 3 is 3 over 4 times 3 is 12. Then plus 2 times 4 is 8 over 3 times 4 is 12. Then we have a common denominator. So we just put the common denominator there. We add the numerators. 3 plus 8 is 11. So I get 11/12 there. So it's the same process for adding and subtracting rational expressions without a common denominator. It's just the fact that you have variables involved, you have to factor stuff. It just gets very, very messy and very, very tedious depending on, what level problem you're looking at. All right, so the first thing we want to do is find the LCD, again, the least common denominator. We learned how to do that for a group of rational expressions in our last lesson. If you don't know how to do that at this point, if you start watching more of this video and you get very, very confused, please stop, go back to that video and watch that and get fully up to speed on how to find the LCD and then come back, right? It's very, very difficult to do this if you've missed a step. The next thing you're going to do is you're going to rewrite each rational expression as an equivalent rational expression where the LCD is its denominator, just like we did with the fractions when we were adding them a minute ago. All right, then we want to add or subtract numerators and then simplify. So very, very simple overall procedure-wise. Just, again, if you're working with something that's, very long and tedious, it just gets kind of irritating sometimes. So let's start out with this first one. We have 7 over 3k cubed plus 12k squared plus 3 over k plus 4. So the first thing I want to do is I want to find my LCD. So the way I do that is I factor each denominator. So if I factor this denominator, I could pull out a 3k squared, and that would leave me with what? I pull that out from here, I'd get k, and then plus, if I pull that out from here, I would have a 4. Now this over here is k plus 4. So really, if I look at the LCD, it's going to be what? It's going to be 3k squared times k plus 4. So 3k squared times k plus 4. So this is okay. I don't need to make any changes to that rational expression. So I can leave it as it is, 7 over 3k squared times the quantity k plus 4. Then plus, for this guy over here, we have 3 over k plus 4. Now what would I need to multiply k plus 4 by to make the denominator the same as this? Well, this is what I'm missing, this factor of 3k squared. So I would multiply the denominator by 3k squared, and to make that legal, I need to also multiply the numerator by 3k squared, because I want to multiply by 1, right? 3k squared over 3k squared is 1. Just a complicated form of 1, but it's still 1. Now if I multiply here, 3 times 3k squared is 9k squared. Let's scroll down a little bit. So this equals, I'll rewrite this first, 7 over, again, 3k squared times the quantity k plus 4. As I just said, 3 times 3k squared is 9k squared. And this is over 3k squared times the quantity k plus 4. So 3k squared times the quantity k plus 4. So now I have a common denominator, right? This denominator is the same as this denominator. So I can just add the numerators. And so basically what I'd have is just 9k squared plus 7 over that common denominator of 3k squared times the quantity k plus 4. And in this particular case, there's nothing I can do to simplify. This numerator here is prime. There's nothing I can really pull out. So I'm not going to be able to really cancel anything here. Again, don't make the mistake that I see so many students do. They'll go, okay, well, this 9 can cancel with this 3, and this is a 3. No, that doesn't work like that. You cancel common factors. This is not a factor. This is 9k squared plus 7. So you can't cancel there. If I had this being multiplied by, let's say, 9k squared, something like that, well, yeah, since this is multiplication here, these are factors. These are factors. And then these would be factors, if that's the problem that I had. So then I could cancel this 9 with this 3, and this would give me a 3, if that's the problem we have. We don't have that, though. So there's nothing I can do to simplify. Let me erase all this. There's nothing I can do to simplify it. So 9k squared plus 7 over 3k squared times the quantity k plus 4 is our simplified answer. Okay, let's take a look at another one. So we have 7x over x plus 1, and we're subtracting away 3 over x minus 3. So the LCD here is very, very simple. Each of these is prime, right? So I can't factor x plus 1, and I can't factor x minus 3. So I just multiply the two together to get the LCD. It's just like if I had fractions where I had 1/5 plus, let's say, 2/7, right? Each of these is prime, so to get the LCD, I just multiply 5 times 7, and I get 35. Well, same thing here. Each is prime, multiply the two together to get the LCD. All right, so in order to change 7x over x plus 1 into a rational expression with this as its denominator, I need to multiply by what? I'm missing an x minus 3. So an x minus 3 is going down here. And so I've got to also do that to the numerator so that it's legal. Then minus. Up here I have a 3 over x minus 3. And what I'm missing here is the x plus 1. So I'm going to multiply by, I have x plus 1 down here. And again, to make it legal, I multiply by x plus 1 up here. So now if we crank this out, what I'm going to get is 7x times x is 7x squared. 7x times negative 3 is minus 21x. And then I'm subtracting away this right here. So 3 times x is 3x. 3 times 1 is 3, so plus 3. Now again, I'm subtracting all of this away. So I'm going to put minus, and I'm going to put parentheses around this. And what that's going to tell me is that to remove the parentheses, again, I've got to change the sign of each term. So don't make the mistake, again, of just putting minus 3x plus 3. Both of those need to have their signs changed. So this is going to be minus 3x, changes from positive to negative, and then minus 3, again, changes from positive to negative. So this is over the common denominator of x plus 1, that quantity times x minus 3. And now we just want to combine like terms. So 7x squared, nothing I can do with that. Negative 21x minus 3x is minus 24x. And then minus 3. And this is over the quantity, again, x plus 1 times x minus 3. Now, here comes part of the problem. Sometimes you're going to get something like this, and it's going to be extremely tedious, right? So I've gone through all that work, and now I've got to factor this to see if I'll have a common factor with the denominator to simplify. So I got to think about two integers whose product, so I want a product of what? 7 times negative 3, so of negative 21, and then whose sum is going to be negative 24. Now, for 21, you basically only have what? You have 1 times 21, and you have 3 times 7. That's it. I can't play with 1 and 21. I can't play with the signs and make that sum to negative 24. I also can't play with the signs with 3 and 7 and make that sum to negative 24. So this is a prime polynomial up here in the numerator. I can't factor it. And so what I'm going to say here is that this is simplified. We have 7x squared minus 24x minus 3 over the quantity x plus 1 times the quantity x minus 3. All right, let's take a look at another one. So we have 5x plus 3 over 3x minus 3. Then we're adding to this 2x minus 7 over x squared minus 1. So again, to find the LCD, I want to factor the denominators. For this one, I could pull out a 3. So I would have 3 times, I would have x minus 1. X minus 1. For here, it's the difference of two squares. So some of these you should start to remember, like x squared minus 1, x squared minus 4, things like that, x squared minus 16. Start to memorize these because as they come up, you want to be able to see that, okay, if I see a binomial here and I got a minus sign, first guy is squared, the second guy is a perfect square, I know I have the difference of two squares. So x squared minus 1 will factor into x plus 1 times x minus 1. Now, I've already got an x minus 1 here, so I don't need to put it into the list of the LCD. What I do need to do is throw in this x plus 1 because it's not currently present. So my LCD will be 3 times the quantity x minus 1 times the quantity x plus 1. So let's go ahead and change each rational expression to an equivalent rational expression where the LCD here is its denominator. So I'll have 5x plus 3 over, I'm going to write this as 3 times the quantity x minus 1. And what I'm missing here is this x plus 1. So I'm going to multiply by x plus 1 over x plus 1. Then plus, over here I have 2x minus 7 over, I have x plus 1 times x minus 1, those two quantities. I'm missing a 3 here, so times 3 over 3. Now, very important, since I'm multiplying by 3, remember to use parentheses. Don't just multiply 3 times 2x and be done. So I'm going to put parentheses around it because I've got to use my distributive property. Okay, so let's put equals here. Let's scroll down and get some room going. And so I'm going to use FOIL here. 5x times x is 5x squared. The outer 5x times 1 is 5x. The inner 3 times x is 3x. So 5x plus 3x is 8x, so plus 8x. And then the last 3 times 1 is 3, so plus 3. Then plus, again, use your distributive property. 3 times 2x is 6x. Then minus 3 times 7, that's 21. Okay, so this is all over that common denominator of 3 times the quantity x plus 1 times the quantity x minus 1. So now, let's go ahead and simplify the numerator. We'll have 5x squared. Nothing I can do with that. I have 8x plus 6x. That's 14x, so plus 14x. And then I have 3 and negative 21. That's minus 18. So 5x squared plus 14x minus 18. And then again, this is over that common denominator of 3 times the quantity x plus 1 times the quantity x minus 1. Now, can I factor this trinomial in the numerator? So 5 times negative 18 is negative 90. So give me two integers whose product is negative 90 and whose sum is 14. Well, let me think about that. I've got what? I've got 1 times 90. That won't work. I've got 2 times 45. Not going to work. I've got 3 times 30. I've got not divisible by 4. I've got 5 times 18. That won't work. I've got 6 times 15. That won't work. Not divisible by 7. Not divisible by 8. Is divisible by 9. It's going to be 9 times 10. And that's all we can really do. So I can't take any of these and manipulate the signs to get a sum of 14 and a product of negative 90. So this trinomial up here is going to be prime, and I can't factor it. So what's going to happen is I'm just going to leave my answer as it is. This is simplified. 5x squared plus 14x minus 18 over 3 times the quantity x plus 1 times the quantity x minus 1. All right, let's take a look at another one. Let's say I have negative 2x over x plus y. Then I'm adding to this 5x plus y over 2x plus 2y. So what I want to do here, again, is start out by finding the LCD. So it's the LCD. This x plus y, I can't factor that. Over here, I can factor out a 2. So I could write this as 2 times the quantity x plus y. Now, I've already got an x plus y here. I just need the 2. So the LCD is 2 times the quantity x plus y. So because this denominator is already the LCD, I don't need to change this rational expression. I just need to change the one on the left. So what I'm going to do, I'm going to multiply negative 2x over x plus y times, what I'm missing here is a 2. So 2 over 2. Then I'm going to add to this the 5x plus y over 2 times the quantity x plus y. Okay, so negative 2x times 2 is negative 4x. And then plus 5x plus y, again, over this common denominator of 2 times the quantity x plus y. If I combine like terms here, negative 4x plus 5x is x. So what this gives me is x plus y in the numerator over 2 times the quantity x plus y in the denominator. And so what I can see is I have a common factor of x plus y. Again, to make this obvious, go ahead and put this inside parentheses and put times 1, right? 1 times anything is just itself. So now I can cancel this factor with this factor, right? Those are factors. 2 is multiplying this, so those two are factors. 1 is multiplying this, so again, those two are factors. So we cancel common factors. What I'm going to be left with is 1 over 2, or 1/2, as my answer. All right, so let's look at one where the denominators are opposites. So we have 3 over 4x minus 5 plus 9 over 5 minus 4x. So remember, we talked about this before. If I see the same terms, but they have different signs. So in other words, I could rearrange this and I could write this as negative 4x plus 5 if I want to. So I have the same terms. I have 4x and I have 4x, but the signs are different. I have a negative and I have a positive. I have 5 and I have 5, but the signs are different, right? I have a positive and I have a negative, right? But same values, different signs. So those two are opposites. And to show that to you, just take one of them and factor out a negative 1. So in other words, you put a negative 1 outside of parentheses, and you change the sign of each term inside of the parentheses. So negative 4x would be 4x, and then positive 5 would be negative 5. Now you can see that these two are the same with the difference of this being multiplied by negative 1, right? So I have 4x minus 5, I have 4x minus 5. Again, this is being multiplied by negative 1. What can I do here? Well, I want you to recall that if I was working with the fractions, let's say 5 over 7, and I'm adding to this, let's say 1 over negative 7. What could I do? Remember, if the denominator is negative and the numerator is positive, the fraction is negative. So all I need to do is erase this, put that here. It's still the same value, and I have that common denominator of 7. Now 5 minus 1 is 4 over the common denominator of 7. It's the same thing here. It's the same principle. So really all I'm going to do, I have the same denominator. All I need to do is take this negative 1, move it into the numerator. Okay, that's all I'm going to do. Very, very simple. So I have 3 over 4x minus 5. And then plus, I'm going to now make this negative 9 over 4x minus 5. Okay, all I did was move the negative from the denominator to the numerator. Again, you can do that. I just showed you that with regular fractions. It's the same. If negative 1 is multiplying this, I can just move it up here and have the negative 1 multiply the 9. That's how I got negative 9. Okay, so now I have a common denominator, and all I need to do is add. 3 plus negative 9 is negative 6. So what I get here is negative 6 over 4x minus 5. Very minimal work. And you can see there's nothing that I could do to cancel anything. So that's my simplified answer. Again, negative 6 over 4x minus 5. All right, so we saved the best for last. Here's one that you might get, something extremely tedious. I have z plus b over 18z squared plus 12zb minus 3zb minus 2b squared plus 3z minus b over 36z squared minus b squared. Now, to find the LCD, I've got to factor these denominators first. And this might take a little while. Now, the first one I can factor by grouping. It's a polynomial with 4 terms. So let me just kind of do this here, and we'll figure out an LCD in a minute. So I can pull out a 6z from the first group. That would leave me with 3z plus 2b. In the second group, I can pull out a negative b. Negative b. That would leave me with 3z plus 2b. So I have a common binomial factor of 3z plus 2b. And so this can be factored as 6z minus b times the quantity 3z plus 2b. Okay, so let's erase this real quick. So we've got this as the factored form of that. Now, when I look at 36z squared minus b squared, what do you notice? You've got 2 terms here, and you've got a subtraction sign. If you see that, and you've got some squared things, you might want to think about the difference of 2 squares. Again, they're going to throw that at you all the time. 36 is a perfect square. It's 6 times 6. Z squared is z times z. B squared is b times b. So really what this is 6z squared minus b squared. So this factors into 6z plus b times 6z minus b. Now, what you can see is that you have this and this that are common. So when I build my LCD, what I'm going to have is 1 factor of 6z minus b. I don't need 2. Then 1 factor of 6z plus b. Then 1 factor of 3z plus 2b. So that's my LCD. Now, what do I need over here? Over here, I would be multiplying by just 6z plus b. So I would have z plus b, and this would be multiplied by, again, 6z plus b. Now, for this one over here, let me put plus. I would have 3z minus b times, what am I missing? Well, I'm missing the 3z plus 2b. 3z plus 2b. Okay, so let's go down here. I know my LCD is this, so let me write this over that. So 6z minus b times 6z plus b times 3z plus 2b. Again, just one that's pretty tedious overall. So I'm going to use FOIL. Z times 6z is 6z squared. Z times b is zb. zb. B times 6z is plus 6zb. If I combine these two, I get plus 7zb. So plus 7zb. And then for the last, b times b is b squared. So plus b squared. Now over here, 3z times 3z is 9z squared. 3z times 2b is plus 6zb. Negative b times 3z is minus 3zb. If I combine like terms here, I'd have plus 3zb, plus 3zb. And then lastly, I have negative b times 2b, so minus 2b squared. And again, all over that common denominator of 6z minus b times 6z plus b times 3z plus 2b. All right, so for like terms, I have 6z squared and 9z squared. That is 15z squared. I have 7zb and 3zb. That's 10zb. I have b squared and negative 2b squared, so that's minus b squared. Then this is all over. Again, we have that 6z minus b times 6z plus b, and then times 3z plus 2b. Okay, so one last step just to check to see if the numerator can be factored. I need to find two terms now because we have two variables involved. So I'm going to treat this last one like if it was a constant, right? Remember, this is usually my c term. So I'm going to say a, the coefficient here, times this guy right here. So 15 times negative b squared is negative 15b squared. So I need two terms that would multiply together to give me that, and that would sum to give me 10b, okay? Z is my squared variable here, so I'm going to treat this b part right here as if it's part of that coefficient of z, right? So 10b. 10b, this is what I'm looking for the sum, negative 15b squared for the product, okay? I know that's a little advanced. We'll do a lot of that in Algebra 2, but for right now, just kind of follow me on this. Forget about the b part. Can you think of two integers that would multiply together to give you negative 15 and sum to give you 10? Well, you've got 1 times 15. That's not going to work. You can't change the signs around and give you that. And you've got 3 times 5. So nothing you can really do with that. So you can't get the number part to work out. This part would work itself out automatically if you got the numbers to work out. So this is going to be a prime polynomial, and we're not going to be able to factor it any further. So this is the simplified answer. 15z squared plus 10zb minus b squared, and this is over 6z minus b, times 6z plus b, and then times 3z plus 2b.